Hi everyone, my name is Ilya and welcome to Leaflet Module 1. So today we are going to be building on some of the GIS concepts that you learned on last week, and we will be creating some interactive maps using the Leaflet package in R. So I'm going to be walking you through this RMD that I created, kind of showing you how to implement the leaflet package, and I'll also be using this knitted HTML file. And I highly encourage you to actually download this file. We'll have this provided, and you can kind of go through and navigate through the file just so you can see what the outputs look like on a bigger screen and not in the R um, kind of console. So yeah, um, let's get started. So as always, we have some resources listed up here at the top. We have this link provided for the GitHub repo for the leaflet package, as well as some extra practice questions or practice materials that you can use to develop your leaflet skills. And these are the libraries that we'll be using. Um, and there's quite a few, so I put some comments down to outline what they do. So the leaflet library is the big one that we'll be leveraging today. And just as a reminder, if you don't already have this installed, which many of you probably won't, you can just run this code and install it. I'm not going to do that because I already have it, but that's what you would use to install this. And then similarly, um, if you don't have the SP package or the janitor package or Viridis package, you would just replace these with this, or you just put janitor into here, for example, and you can install it. Um, so the leaflet package is the package that allows us to do interactive mapping. The SP package is the package that allows us to use spatial data points, which we will get to. The janitor package is this neat little package that I wanted to show you guys. It's a quick little way for you to clean the names of your libraries, um, or clean the names of your columns and your data frames. And then the Viridis package is the accessible color palette library that um, was covered in the accessibility lectures. So let's move further into the data. So for part two of this module, we're going to be doing some data pre-processing, as with kind of any analysis or data visualization. So we're going to be leveraging this open source hospital data set from ArcGIS Online. The data set provides the locations of all the hospitals in the United States, which is pretty cool, as well as some of the information about them. So if you want more info on the data set, you can navigate to this link, um, and you can read more about it. And then, so the first thing that we're going to do here now is we're going to import the data set. And I decided I was gonna add a few kind of dplyr commands into here, just to remind you that you can perform a filter, or kind of manipulate your data at the initial import. So we're only looking at United States, or like the states um, in the country for this module. So uh, we're filtering out Puerto Rico, and I'm using this clean names function. So this is from the janitor package to clean up the column names in the data set. So they're going to be all lowercase. and all punctuation is replaced with underscores. So the data frame will have neat column names that are now in snake case, which R loves. So yeah, I just wanted to show you that as a quick little trick that you can use in further data analyses. So what we're going to do here now is we're going to look at the data. I just wanted to outline that there's 34 features in the data set, which is just another fancy word for columns, as we can see here. And there's a lot of observations. There's 7,937. So this data set can provide some pretty rich analyses and visualizations if you wish to do so in the future. And for the purposes of this module, we'll only be leveraging 7 of the features, which will be latitude, longitude, name, address, beds, which is the bed capacity of each hospital, telephone of each hospital, and the owner, which this column is representing the ownership type of the hospital, whether it's private, nonprofit, government owned, which can be pretty important. So here I ran a head of the data and then a summary. So we're going to look at the head first, just to take a quick look at what our data looks like. It's always good to just glance at it. And then I also output a summary. So this is nice to see differences between categorical variables, continuous variables, stuff like that, and just so you can see like how the data is distributed and if there's anything wonky here. So we're going to be pretty deliberate here. So we only really want to look at the columns that we're interested in. So just notice here that in the beds column, there's this value for negative 999. And just keep that in the back of your head right now. It's kind of nonsensical. So as we're looking at the beds column, we realize that, yep, there's non-negative values, which is odd for something that should not have a negative value. That's pretty nonsensical. And I wanted to highlight here that negative 99 is often used to signify a missing value. It's pretty common in healthcare data. So what we're going to do to address this is we're just going to filter out all negative values from this column. And I'm actually going to filter out and only keep hospitals that have over 200 beds. And this is just to kind of decrease the sample size a little, so our visualizations are a little bit less cluttered, at least for now. And then I will provide further information moving forward on how we can use all the data and make the outputs look very neat in future modules. So stay tuned for that. And then the second thing that I want to look at is the owner column. And as we can see, let's look at the data frame again, and let's navigate to the owner column. So we see that all of this is uppercase, which takes up a lot of space. And also there's these government kind of prefixes to each of the government ran hospitals, but they have district and local. Now there's also federal and state level hospitals here. So one thing I want to do is I also want to replace this government and dash with gov. So we will kind of just shrink the size of that, and that'll be important when we start visualizing the maps, just so our legends don't take up a bunch of space, and um, so the maps are just a little bit more crisp. And what I'm going to do here is I'm going to use the str replace function, which is part of the string R package. And I'm going to select the owner column. I'm going to search the column for government dash, and then I am going to replace that just with gov. And then I'm going to nest that within this str to title function, which is also part of the string R package in tidyverse. And this just will make all of the values lowercase with the first letter of each word being uppercase. So kind of what you'll see it often in a title. And I'm gonna wrap that all into a mutate. So we're just gonna write over the owner column. So the column itself is gonna change, but we're not gonna add a new column. So I'm gonna run that. And let's just quickly take a look at this output now and see what it did. So we see that our sample size got filtered down a lot. And now, perfect, we have gov here instead of government, and this is all now in title case. So that's exactly what we wanted. So now that we're done kind of pre-processing our data, our initial data frame, let's create a spatial points data frame. So to build a map leveraging Leaflet, we need to transform our data into a spatial points data frame. And an SPDF is a data structure that's commonly used in geographical information systems, GIS, and spatial analyses. And this is a specific data format that combines the attributes of a traditional data frame or a table with spatial information such as coordinates represented by latitude and longitude to represent like point locations on the Earth's surface. So in order to do that, what we're going to do here is we're going to call this function, which is part of the SP package, as I alluded to earlier. And we are going to specify what our coordinates are. And what we're going to do here is we're going to take our data frame that we're pulling from, and we're just going to subset these columns. And just as a quick reminder, what we're doing here is indexing. And everything to the right of this comma is columns, and everything to the left would be rows, which we're not going to use today. And the way you index is you use these brackets, and you use one pair of brackets to signify that you're indexing from a data frame. So what we're going to do similarly here is we're going to specify what data we're going to use now. So this is kind of the information that are going to be represented at each of those points. So this is a pretty big distinction. So these are the coordinates, which you don't include here, or you don't need to include here, and you definitely can. And the data. So this is the information regarding these coordinates. And then we're going to be specifying this proj for string argument, which is just the projection information for the data. You don't really need to worry about that. It just uses a coordinate reference system, which as a default rule of thumb, if you're using the United States, this is the coordinate reference system that you should be using. And let's say you wanted to create a map of India or somewhere else like Brazil, you can just Google the coordinate reference system for that country and just copy and paste it into this code. So that's a pretty simple fix. So now that we have created the spatial points data frame, you see it's right here, we can get to the fun part, which is mapping. So the first part here is we're going to create this initial map layer. And I wanted to emphasize this layer part because it's very similar to what we do using ggplot, where you kind of build one layer on top of another layer. And we're going to be doing almost the exact same thing here with Leaflet, where we're going to be building layer on top of layer. So for the first part of this, what I'm doing here is I'm creating a map object. I am running this leaflet function, which is similar to ggplot. And then I'm adding just a pipe here just to set the view to zoom to the United States. And as I mentioned previously, if you're using India, creating a map of India or a map of like Southeast Asia, or a map of Brazil or South America, you're going to want to just play around with the zooms here. But this is the general code to do that. So this just creates the initial layer, but you won't be able to view anything yet. There's actually nothing on the map until you add like a tile, which we're going to get to here. So these are map themes, and specifically they're called kind of add provider tiles or add tiles. And this is used to determine the topography of your map. And you can navigate to this link here to just look at more presets. There's so many available. I just included a few here. So I'm going to run all of these. And I'll kind of walk you through each of them using this HTML package. So right here, we are using the basic themes. This is just add tiles. It's not even add provider tiles. So that's just the default theme. And what we're going to do here is you can just look to see that this is what a default theme would look like if you are using this tile. So this is often what you'll see like in a Google map. It looks very similar. You have a bunch of roads, water boundaries, you have forests, national parks. So it's really granular, right? And this is personally my favorite. It's this minimalistic theme called Carto DB, and this is how you would use this. You'd use the add providers function, and you would just plop that code in, and it's just kind of this black and white theme. It does show like this kind of green space to show that there might be a national park around, and it gives you the road. So I like this personally because it really allows the user to focus in on what you're trying to show them, which is often like specific geographic points. And then here's another add provider tiles theme. And here's another one. And this is actually using Esri's package. They're the company that creates ArcGIS. This is an implementation where you can pull directly from a website. And then this is just another theme, so feel free to play around with these as you see fit. And now I'm going to navigate back to here. So now that we're back into the RMD, let's move forward to adding markers onto our map. So what we're going to do is we're going to use this add circle markers function, which allows us to add our data points from the spatial data frames that we created onto the map. And for the remainder of this module, I'm just going to use this provider's CartoDB positron theme. And you guys can play around with this and switch it up however you want. And kind of the structure, the way I've coded this out is I have this line kind of indicating what's old and what's new. So above here is old code that we haven't covered before, and then this is the new code or what's been modified. And I'll keep pointing that out as we move forward. So what we're going to do here is I'm just going to rerun this for good measure. And this is the output that we're going to get. So now we have a map of the United States with the data points mapped geographically to the appropriate latitude and longitudes. So the way we did this is we're using this add circle markers function, as I spoke about earlier, and we're passing the SPDF hospital's spatial points data frame through this data argument. I am selecting white to be the color, and I want to note that this is the outline of the points, and I'll zoom in here onto the map. So as you can see, the more you zoom in, you can see that you have these little white outlines. And the reason I do that, and you can choose a different color outline, the outline really helps visualize when you kind of have a clustering like we have in Phoenix here in Los Angeles and in Vegas. And it just allows you to discern that there's kind of multiple markers stacked on top of each other. So that's just a nice little like stylistic thing that you can use. And then the weight, this just determines the weight of the outline. So the higher you increase it, kind of the thicker your outline will be. And the more you decrease it, the thinner it'll be. The fill color is, this is supposed to be blue. The fill color is just like the color that you actually fill the circle marker in with. And the opacity, we've covered this in ggplot, is allowing us to kind of see through, have a little bit of transparency between the points. So I'll zoom in a little bit more. Yeah, so right here in Phoenix, you'll see that some points appear a little bit darker. So that indicates more density of spatial of these circle markers, and the lighter points kind of indicate that there's just one there. And this is similar to like the alpha measure in ggplot that I was trying to allude to earlier. And then the radius is the size of the circle. So if you increase the radius, the size of the circle will go up. You decrease it, the size of the radius will go down. So I hope you got the gist there. So now we're going to do some more modifications. I'm just going to cancel out of these that I ran because it's kind of taking up a portion of my screen. I don't want that to interfere with the code chunks. This is where you have the added benefit of using the HTML file to kind of as a supplement to this. So now what we're going to do is we're going to modify the marker information. So like, what is this marker telling us? So what we're going to do here is we're going to add pop-ups in this implementation. So this code is all the same, and I have indicated this code, this is the new stuff in between these two lines. So we have this closing parenthesis here, and I just indicated that this isn't like adding a new layer. This is still within the add circle markers layer. So what this is going to do is it's going to allow us to have a clickable marker that presents information regarding the spatial data point. So we can click any one of these markers and it's going to give us some of this relevant information that we indicated earlier. And it's pulling all of this information, from the spatial points data frame. So you can see that's pretty cool. It's pretty neat. And the way we did that is we use this pop-up argument, and I also used this paste feature function where it allows you to basically type out a phrase and then use that to separate with a comma, put in your like the name of your column in the data frame, and then add another comma, and then add a break. And this break is just a return. So it's just like HTML syntax, because we're using an HTML output. This just means return to the next line. So it just gives this a nice cleaner output. So instead of, let's say you're clicking on here, instead of the output just being VA Medical Center, Menlo Park Division, and then just like this output and then 715, you have some context as to what each of these things are telling you. You know that this is the name of the hospital, this is the address of the hospital, you know that this is the number of beds, this is the phone number, etc. And this is probably one of my favorite features. This is a go-to that I often use. So now I am going to contrast that with labels. So labels are hover markers that present information regarding the spatial data points. Instead of clicking, you just hover your mouse over a point and it will display in information. So here we just hover and it displays the name of the hospital. And just a quick contrast between the two is with the label, everything's done on one line. You can't have you can't add like another line for another feature. Everything's kind of done, just you don't have as much space basically, so you can communicate less information. So that's why I opt for the pop-up, because I just think it's more efficient at communicating more information. And as with the pop-up, this code is all the same. The only difference is now I am adding this label argument instead of pop-up. And I'm using the similar paste formatting that I used earlier. And I also added this label options argument here, where I can indicate what font I want to use, the color of the font, if I want to italicize or bold it, and the font size. So that's why it appears italicized. And I just gave you this code, so you can just reproduce this and repurpose it with whatever kind of style you want. So there's that. And then now, lastly, for this chunk of marker information, I'm going to walk you through clustering. And this is super simple. All I did was just add this line of code in, signified by this region. And as you can see here, it clusters the hospitals or your data points geographically. So let's say you want to zoom into California, you start zooming, and now the clusters kind of start deaggregating. So the more granular you get, now you're going to start seeing more points popping up. So I think this is a cool feature. It's cool for organization, just so you can kind of, you're not overwhelmed by all these markers all over the map. So that's nice. And you can, click on these and then it'll also differentiate. So that's just a cool little trick you can use as well for your map. So now we want to be complete. So we want to add a legend to our map. Um, yeah, I just wanted to get rid of all of that space at the bottom. So what we're gonna do here is with this code, I just used the pop-up code as a default here. And then this is the only new codes. This is just adding a legend. So what we're gonna do is we're gonna use this function called add legend. We're gonna pipe into that. So this is indicating that we're adding a new layer now. Whereas here in the previous examples with the markers, we were doing everything within the circle markers layer. Here we're adding an additional layer. So we're going to indicate that we want the position to be to the top right of the legend. We're going to title the legend marker colors. We are going to call the label the markers hospital, and we're just going to input the color that we're using here. And we're also going to make the opacity 1 so you can't see through it. Sometimes you can very lightly see through it, but it's not enough to like interfere with your map. And it's distinct enough to be a legend. So this is the only difference from the code before, and we have our pop-ups as previously denoted. So now to more fun stuff, we're going to do some color modification. So first, I'm going to show you how you would display continuous variables on your markers. And what we're going to use is we're going to use the beds column. And the big differences in the code are right here, where we're kind of creating this color palette object where we're using this color numeric function. And all we really have to do is just indicate the palette that we're using. And I'm using the Viridis palette to be accessible to those with disabilities. And I'm saying I want 7 Viridis colors. That's what this is. And then the domain is just which column are you using? Do you want the color to reflect? And I am saying that I want the beds column here. So this part is all the same. The one difference here is that we, for the color, we just need to indicate that we're using this color palette object here. And we are now passing like the beds column through it. And lastly, we're also updating the legend to reflect that color change. So what we do here is we add, so the legend actually has an argument for pal, which means color palette. And then we're just passing the color palette that we're using through here. And then we're indicating the the column that we're using, and also we're changing the title to be appropriate of what we're visualizing. So now what we're getting here is this output. So now you can see that the circle markers are changing colors adequately to adequately reflect the scale. So if we, zoom in, we can now see that the purple colors, we can zoom into Chicago, for example, because there's a big density here. And we will see that you can now discern kind of the hospital size by the color, by the bed capacity. So this would be a larger hospital over here. Oh yeah, this is the University of Chicago Medical Center, so that's a pretty big hospital right outside of Chicago. And you have some smaller hospitals here as well. So that's one implementation using continuous variables. And now we're going to do a very similar thing, only we're going to use categorical variables. So the only difference is in this code from the previous code is this line right here, where in the color palette, where we're just changing the domain from beds to the owner column. Similarly, right here, we're changing the color to the owner column. And right here, we're changing values to the owner column. And we're also changing title to owner. So I'm going to move that right there. So we're going to run this. And there's the output. So now we get this nice map that's color blind friendly, and we can see what the different like ownership types are. So it's whether it's the district government, federal government, local government, state government, nonprofit, whether the data was not available, and proprietaries, that's privately owned. And we still have all of the relevant pop-ups. So that concludes our first Leaflet module. I hope that you enjoyed this. So Leaflet module 2 will pull on some of these concepts from this module, and we'll teach you guys how to further increase interactivity by adding layer control. So thank you so much, and I'll see you at the next module.